In this question, we know the joint probability density function of xy equals to fxy equals to 1 divided by a multiple y to the power of 2 and multiple x. And in the first question, the according to the statement in the question, we can write the definition region. Should satisfy y is smaller or equals to 1 and x is smaller than y and x is greater than 1 divided by y, and so we can draw the definition region. And the sheet area is the definition region. In the second question, we want to find A so that fxy is a valid joint density function, and if fxy is a valid joint density function, it needs to satisfy that dxy fxy dx dy equals to 1. And we can calculate this integral. We can find that the y is between 1 to the infinite. So we first calculate the integral of x, and the y should in the x, we can find that if we draw a line, it will first have a point with x equals to 1 divided by y, and then it will have a point with the line x equals to y. So the when we calculate the integral for x, the upper limit should be y. The lower limit should be 1 divided by y. And this part, because the ln y, when we calculate the derivative of ln x, its result is 1 divided by x, so we can calculate this part, which is ln y minus ln 1 divided by y and dy, and this part equals to 2 dy, and then we can let the ln y equals to t, so the integral upper limit and lower limit will change, and it will change to, and because we let len y equals to t, so y is equals to e to the power of t, and t is between 0 and infinite, and so it equals to t divided by a e to the power of 2t d et, and this equals to t divided by et dt, and we can calculate this integral, and which equals to t e and we can then using the math conclusion to calculate this parts, and which equals to 2 divided by 2. It should equals to t multiple e to the power of e to the power of negative t, and it's between 0 and infinite, and minus e to the power of negative t dt. And it is obvious that this part should equals to 0. And when t is equals to 0, t multiple e to the power of negative t is e0. And when t is approached to infinite, we can use the L'Hopital theorem, L'Hopital's rule. We can it is t when t is approach infinite, t to the divided by e to the power of negative e to the power of t. We can calculate the derivative of both the upper side and the lower side, which equals to 1 divided by e to the power of t. And in this format, we can find that it is equals to 0. So this part equals to 2 is divided by a, and because 2 divided by a is equals to 1, and so a equals to 2. In the third question, we want to find and draw the marginal density functions of x and y, and fxy equals to 1 divided by 2 multiple y to the power of 2 and multiple x. So according to the definition region, when we calculate the marginal density function of x, we can find it should divide it into 2 parts. In the first part, when x is between 0 and 3 parts when x is smaller than 0. It is obvious that in this part, the fx should equals to 0. And second, when the x is between 0 and 1, it is obvious that using the definition fx equals to the when we draw a line in this part, we can find the integral should from 1 divided by x to the infinite, and dy, because we want to calculate the marginal density function, so we need to calculate the integral for y, and we can calculate the result. Which should equals to 0 plus 1 divided by 2, and equals to 1 divided by 2. In the third circumstance, when x is bigger than 1, in this part, when we draw a figure, we can find the fx should equals to the integral from x to the infinite. And it equals to x to the infinite, and so we can write the analytical format of fx, which equals to 0 when x is smaller than 0, and 1 divided by 2 when x is between 0 and x and y, and 1 divided by 2 multiple x to the power of 2 when x is bigger than 1. And so we can draw the figure of fx, and the figure should be one divided by 2. This is fx. And for the y, we can find it is obvious that if we draw a line, we can find the 2 point, and the fy when y is smaller than 1, it is obvious that fy equals to 0, and when y is greater or equals to 1, fy equals to this point is 1 divided by y, and this point is y. And the result is ln y divided by y to the power of 2. And so we can write the fy as equals to when y is smaller than 1, it is 0. When y is greater or equals to 1, it equals to y divided by y to the power of 2. So we can draw the figure. of y. This is y. And in the fourth question, we need to verify fx and fy are valid density functions. So first we verify x. In the third question, we know the we know the non-zero definition domain of fx is x greater than 0, and so when we calculate 0 to 1 plus the integral from 1 to infinite, 1 divided by 2 multiple 2 to the power multiple x to the power of 2 dx, and we can find this part should equals to 1. So this is verified for x. Verified for y, we can find that the non-zero definition for fy is y beyond greater or equals to 1. So we can write then y divided by y to the power of 2 dy. And we can also, using the same method in the first question, in the second question we let ln y equals to t, and so that we can write the integral to this format, and this part it is equals to 1. So this is the second question.